Okay, I've pulled the board over a little bit so I can write on it without blocking it. If I'm writing over here, it's very difficult to do that without blocking the board. So I'm going to demonstrate how to construct a normal curve. Simple enough. I start with a horizontal line and a vertical line in about the middle of the horizontal line. And since I'm off to the side, it's going to be a little difficult for me to judge right angles. Doesn't seem I did a very good job with this one. Okay, so I've got a line here, a line here. They should be perpendicular. This one perpendicular to this one. Then I mark 2 points. This is going to be my center, my 0 point. Mark 2 points to the left and 2 points to the right, spacing the points equally. I see also if these points are equally spaced, I didn't do a very good job of hitting the middle of that horizontal line, did I? Okay, then above this point and this point, the points that are 1 unit to the right and left of the center, I draw 2 lines, again perpendicular to the horizontal line, that are 60% as long as this one. Now 60% I'm going to say is about, let's see, half would be right about here, 60% I'm saying is here. So 60%, 60%. Maybe I did that well, maybe not. Yeah, you try to do better. Then I draw points here and here, or little lines here and here, again, perpendicular to the horizontal line, that are 1/7 as high as this line. Now 1/7 is pretty easy to do. I can get 1/8 very easily. I just divide this line into 2, divide that into 2, and I've got 1/4, and then take half of that, and I've got 1/8. So that my 1/7 is going to be just a little bigger than that 1/8. So I get maybe this and this. Now, you can probably do better than I did, but let's just take that. And now I'm going to draw my normal curve, my bell-shaped curve. I've got a guide. Simply start down here. This is not coming out very well. This chalk is kind of running roughly over the board, but right there is my best attempt at this normal curve. This one turned out much better. It's one of the better ones. I don't usually do that well. Usually do a little better than this. Okay, then I label. Okay, I said this was my middle point. This is my 0 point, and I'm going to say that z equals 0 here. This is going to be a z-axis, which can be relabeled to be an x-axis or any other axis. But right now, with our fundamental normal curve, we have z equals 0 here, z equals 1 here, z equals 2 here, -1 here, -2 here. Now, that's kind of bunched up. If I write it a little bit too narrow or write it too small to label these z's in here, I could just do a z colon over here and then put -2, -1, 0, 1, 2. Now, that's exactly what I did here. Let's see how the results that we got for the 4 flip, for the number of heads on 4 flips, might relate to the bell shape, the normal curve. Now, I'm not going to get into just where the standard deviation fits into this right now, although I will say that standard deviation should be equal to 1 unit of z. Okay, so 1 standard deviation is this distance, or this distance, or this distance, or this distance. Well, actually, I kind of have used that. Using the standard deviation of 1, I draw my first histogram from -1/2 to +1/2. It's going to have a width of 1. Now, if I wanted to do it really accurately, I'd use a width of 1.03. Or I could go even more accurate than that. That's a rounded error. I mean, a rounded result. So I'd go like from -0.515 to positive 0.515. Here I've just gone from negative 0.5 to positive 0.5, negative 1.5 to negative 0.5, negative 2.5 to negative 0.5, and similarly over here. So I made all these 1 unit wide, centered at z equals 0. And here are my bars according to that, using the convention that, and I didn't do it really well, that the area between here and here within the bar should equal the area between here and here under the curve. Now it's clear that the area under the bar here is less than the area under the curve, so I didn't do a very good job on that. I did a better job over here. This area that here's a region under the curve that isn't under the bar, but then here's a region under the bar that isn't under the curve, and they have approximately equal areas. And more or less true down here and over here as well. If I do that, the result should be very close to the normal curve, to the shape of the histogram that fits these relative frequencies. Okay, so this should have a height of 1, this 4, this 6, this 4, this 1. If this is 1, this is 4, this is 6, and so forth. Now if this is 1, it looks like this is more like 3, this is more like 5, but that's just an anomaly of the way the thing was drawn. And of the fact that when n equals only 4 coins, you don't really fit the normal curve all that well anyhow. It's not important yet that you understand every detail of what I just told you, but you should see, first of all, you should know how to draw a normal curve. Second, you should understand that the histogram for 4 flips does a pretty good job of fitting the normal curve. And we'll see later that the histogram for greater numbers of flips does an even better job of fitting the normal curve if you use the width of each bar relative to the standard deviation. Okay, so if the standard deviation is like 3, then each bar would only be 1/3 of a z unit wide. Again, I'm not going to go into all that. We need to do that in detail, but just a little premonition, a little foreshadowing of what might be to come.